We all learn about the fundamental dimensions, the seven fundamental dimensions in our school days. We know that the seven fundamental dimensions are mass, length, time, temperature, electric current, luminous intensity, and the amount of substance. And we know that the derived dimensions are dimensions of velocity. Dimension of velocity is a derived dimension. Dimension of acceleration is a derived dimension. Dimension of force is a derived dimension. So let me ask you, can we choose this derived dimension as the fundamental dimension? And the length, mass, time, etc. as the derived dimensions? Can we choose? The answer is yes, we can choose. This is the basic idea of natural dimensions. In natural dimensions, we choose the dimensions of the physical constants as the fundamental dimensions. So, what are the physical constants in our nature? The physical constants in our nature are Planck's constant h cross, Newton's gravitational constant, Boltzmann constant, velocity of light, etc. are the and the Avogadro's constant, etc. are the physical constants in our nature. So if we choose the dimensions corresponding to these physical constants as the fundamental dimensions, then that dimension is called the natural dimension. So we have a lot of examples for these natural dimensions. For example, stone is natural dimensions and natural units, atomic natural dimensions and natural units, quantum chromodynamics natural dimensions and natural units, Planck's natural dimensions and natural units. We actually focus on these Planck's natural dimensions and natural units in our studies. And these Planck's natural dimensions are extensively used to study theoretical physics and also in our particular chapter. In Planck's natural dimensions, we choose the dimension of velocity, dimension of action, dimension of gravitational constant, and Boltzmann constant. Dimension of this Boltzmann constant as the fundamental dimensions. So, if we choose these as the fundamental dimensions, then we know in our old fundamental dimensions, length, mass, time, etc. And the corresponding one unit in SI unit is for length is meter. 1 meter is the corresponding unit. For mass, 1 kilogram is the corresponding unit. For time, 1 second is the corresponding unit. So let me ask you, what are the corresponding units for these new natural dimensions? For velocity in Planck's units, the basis or the one unit of the velocity in Planck's natural dimensions is c, the velocity of light. So 1c is the one unit of this natural dimension v, and 1 h cross or the one Planck's constant is the the unit of the action, and the value of the Newton gravitational constant is the one unit for this natural dimension g, and the value of Boltzmann constant is the one unit for this the Planck's natural dimension kb. So these are the Planck's natural dimensions, and these are the Planck's natural units. Planck's natural units. Now we have these as our fundamental Planck's dimensions, and this length, mass, time, etc. as our derived dimensions. So how can we express these derived dimensions in terms of our fundamental natural Planck's dimensions. So let me do that. For example, let us take the derived dimension length and let us express it in terms of our fundamental Planck's natural dimension. So L is equal to, dimension of L is equal to the dimension of the velocity to the power A, the dimension of the action to the power B, the dimension of the gravitational constant to the power C, the dimension of the Boltzmann constant to the power D. So our task is to find the values of A, B, C and D. For that, let us express V as L t raised to minus 1 to the power A, and the dimension of the action as M L square t raised to minus 1 to the power B, and the dimension of the gravitational constant as we know that it is M to the power minus 1 L cube t raised to minus 2 to the power C. And we know that the dimension of the Boltzmann constant as M to the power 1 L square t raised to minus 2 k raised to minus 1 to the power D. So on equating the powers of LHS and RHS, we get A is equal to B is equal to half and C is equal to minus 3 by 2. On putting these values back to our equation, we get the dimension of the derived dimension L as root of GA over V cube. So let us think what's the value for the derived dimension L if we choose the unit values for the fundamental dimension. The unit value for the fundamental dimension G is the gravitational constant G, and for action it is h cross, and for velocity it is speed of light. If we choose the unit values for this fundamental dimension, then the derived dimension L is called the Planck's length LP. In Planck's natural unit system, LP is 1 because G, h cross and C are 1 in Planck's natural units. One of the main use of Planck's units is our equations get simplified a lot. So let us take E is equal to mc square in Planck's units, and we can see that it becomes E is equal to m, a simple equation, because C is equal to 1 in Planck's units. So let me ask you, is the dimension of energy and mass are same in Planck's dimensions? No, the Planck's dimensions of energy and mass are never same. They are not same. Why? It's a task for you to verify they are not same. So for that you just need to use the method that we already talked. So it's actually a task for you. Find the dimension of energy and find the dimension of mass in Planck's dimensions. And also it's the first part of the task, and also the second part of the task is find the dimension of time, find the dimension of temperature in Planck's dimensions, and also find the value. It's actually the third part of the task is find the value of these. Find the value of Planck's length, Planck's Planck's second, Planck's temperature, and also Planck's mass in SI units. We know that in Planck's units these all values are 1.